Welcome to Season 3 of Food Waste Matters, the podcast where we have those conversations about the fight against food waste. So each episode we talk to people who are finding smarter ways to make the most of our food, from farmers and businesses to researchers and industry leaders. But reducing food waste isn't just about the environment. It's also about supporting our local growers, saving money, and making sure perfectly good food doesn't go to waste. So if you're looking for practical ideas, real conversations, and actionable solutions, Food Waste Matters is for you. So on this podcast, we speak with people tackling food waste head on, whether it be in the paddock, the packing shed, the kitchen, or in a food lab. Each episode, we share practical ideas and real-world examples to help you reduce waste, save money, and make better use of our food resources. And in today's episode, we are heading to the food lab. So joining us on this episode is Pia Winberg, co-founder and CEO of Venus Shell Systems. Based in the beautiful Shoalhaven region of New South Wales, Venus Shell Systems capture carbon and nutrients from industrial emissions to grow seaweed, then turns those seaweeds into ingredients for healthy foods and supplements, nutritious animal feeds, and even biodegradable materials. So basically, what was once a waste stream becomes new products that help businesses hit their sustainability targets. So Pia, welcome to Food Waste Matters, and thanks so much for taking the time to speak with us today. And I just want to get right into it. So can you tell us about the inspiration behind Venus Shell Systems and how the company came about?
For sure. Yeah, Venus Shell Systems goes back a way, and it's about a 25-year journey of me coming to this point and working out. Really what I've been working out is how does the theory of Earth's recycling systems relate to what humans are doing, what we're doing wrong, and how we can fix it. So it's really a convergence of the science of planetary systems that I studied at Stockholm University back in the mid-90s, and the realization that one of the biggest issues around planetary sustainability comes from the food manufacturing processes and the extreme wastage and linear flows that the food manufacturing industry practices today. And it stemmed, my focus and interest was in the marine environment. And it's actually the case that all food waste, the absolute end of the line, all ends up in the oceans. People might think about food waste behind the supermarket bin or something like that, but it all ends up, whether it's through the sewage, through rainfall and runoff, all of it ends up in the coastal zone. And it's actually creating one of the biggest stressors in the coastal zone. And that's really my mission, is that I started Venus Shell Systems initially as a way to recover the lost nutrients from the coastal system, but also realizing that humans don't actually pay to clean up. Try getting your kids to clean up their bedroom. It's not a natural human behavior. And then looking at what are the incentives that we can use. And really, it's turning that nutrient waste and seeing it as a resource back into food. And the key biological tool we can do that with is seaweed. So that's what we do. We cultivate seaweed as a tool for remediation and recovering nutrients, but making food and valuable protein out of that lost waste.
So how does your technology work? I know, it's, and I don't want to simplify it at all, but, what makes it unique in the seaweed cultivation?
Yeah, so there's a number of unique angles. So seaweed isn't unique. And I'm not, here in Australia, people think, oh, this is novel. We're using seaweed in food, although people know that it's used in sushi. And so I see what we're doing is sort of innovative because we're using seaweed as food. That isn't innovative. Human societies have eaten seaweed for millennia. Even the Stone Age people, if you go and do archaeology on their teeth, the dental plaque has got seaweed molecules in it. You know, from anywhere, any part of the world, Stone Age people have these residues. So humans have lived and evolved with seaweeds for our survival. And indeed, a whole lot of the trace elements that are now missing in land-based systems, they're all in the oceans and they exist in seaweed. And so even if seaweed hasn't been like the staple, like say a potato or wheat in the food system, it's been an essential because it delivers a lot of minerals like iodine is the well-known one, but even things like magnesium, selenium, iron, everything ends up in the coastal zone and seaweeds can return it to our food system. So us putting seaweed into the modern food production system, that's where the innovation is. It's rediscovering seaweed's power in the original state and putting it into the giant monolith of modern food production and using it to regenerate those nutrients. So that's the seaweed angle of it. The other innovative part of what we do is that we actually are looking at how do you translate the nutrient waste streams and where they are from existing large industries and actually use that to turn into seaweed and then create novel foods that the modern food system will accept. So we actually are integrated now with a large wheat refinery, one of the largest wheat refineries in the Southern Hemisphere. And wheat being one of the biggest staple food sources on the planet for protein, fibers, and even trace elements and nutrients. However, this wheat production ends up being concentrated in a processing facility somewhere around the planet. And here in Australia, there's one on the south coast of New South Wales. And we've actually shown we can catch the dissolved nutrient waste streams, specifically nitrogen as well, flowing from this wheat refinery and catch it into seaweed, which has no roots, shoots, or any waste products. So the only waste products we generate from the capturing of this nutrient is oxygen and clean seawater. And we then turn that nitrogen back into a protein that's laden with trace elements from the seawater, and we can put that back into the food system. So one, it's seaweed and its innovation in modern food systems. And two, it's using the seaweed to directly capture nutrients from an existing industrial food processing plant and creating zero waste and a positive gain in using wasted resources.
So can I ask a very layman's question? Does this happen in a lab or does this happen on a seaweed farm in coastal regions, this capturing the nutrients?
Yeah. This actually happens at scale right at the interface between the coast and the ocean. And we have giant pools that are there to catch the nutrient before it hits the coastline. Most seaweed in the world today is cultivated at sea, and that indeed can be the solution as well. Placing ocean-based seaweed farms along coastlines does actually capture nutrients, regenerate oxygen, and solve the problem as well. However, it's even more beneficial if we can catch it before it hits the coastline and create any of the overload of nutrients in that sense. And it's also more efficient from a product quality and a nutritional consistency point of view. So because we have controlled pools with one seaweed, no other species getting in the way, and we can turn that protein when we control the flow to the seaweed to a really high and set amount of protein. Nitrogen turns into protein, and we have 40% protein in our seaweeds because we can control that process. Now, it does come from a lab originally because that's where I stem from, where it's beakers and drops. And that's also part of the challenge that exists today in some of the innovative food waste and sustainability technologies, is that they're all done in labs. And that's where I had to leave universities behind, because you're not going to solve the problem by telling the world how it's done in a lab and how you should do it in the real world. That's a major step, and that's the step that we've taken through Venus Shell Systems.
So Pia, in these ponds, you capture the nutrients, you turn the nutrients into protein, How does this happen? So then you can use these proteins in other food products.
Yeah, so people aren't 100% aware that the nitrogen that we rely on for our fertilizers in food and everything else is that nitrogen comes from large industrial atmospheric capture industries in the Northern Hemisphere. It sounds pretty bizarre, but half of the food we eat today is through a sort of artificial lifeline of pulling nitrogen out of the atmosphere and putting it into fertilizers, urea, nitrates. You will remember the giant explosions that were in Beirut and blew up half the city a few years ago. That was one giant pile of nitrogen fertilizer. And that fertilizer was captured from the atmosphere. And the reason we have to capture so much nitrogen from the atmosphere is because it is the foundation of proteins and the DNA in our bodies and the collagen in our skin. And without it, we just won't survive. In fact, if we turned off these giant nitrogen capturing factories in the Northern Hemisphere, half of the population on Earth would not be alive today. We couldn't feed them. And so it's very ironic that we pay all this money and rely on such a, artificial synthesis of essential nutrient for us from the atmosphere. We ship it all the way to Australia, grow our food on it, and then we just discard it as a burden and a waste into the coastal zone, when we really should be seeing that as the resource that we should recover, because it costs so much to create it in the first place. And this is sort of a journey people are blind to, because nitrogen, it's not like a banana skin rotting in a pile of compost. People have a difficult time understanding the concept of these food waste, food process systems. And so that's really what we have to do, is to show, demonstrate through example, what we can create from looks like nothing, just looks like water in a coastal zone, add some sun, and suddenly you get a protein-rich product brimming out of these pools. It actually didn't come from nowhere. It's come from the extreme loads of nitrogen that are there today. And people just are oblivious to that. They can't see it. And so we've had to demonstrate by just going out there and doing it, and then showing someone a box of muesli that has 10% seaweed in it, that yes, 10% of this product has actually recovered wastes, protected coastal ecosystems just through the natural chemical capturing of nitrogen that seaweeds can do. We've had to train and tame certain seaweeds that we can do this with in the giant pools. So there's a whole lot of water chemistry, biology, species identification that we've also had to put into this work. And we've landed on a very nice protein-rich Australian-only species that we're very proud to be bringing to the world as Australia's contribution to what is already a large global seaweed industry. And we love sushi, but seaweed ain't just sushi.
So you're working with a large industrial sector, like the wheat industry. How do you then capture that data, the environmental, the ECG goals? How do you capture that data?
Yeah, so we can actually literally convert seaweed growth in biomass into an amount of oxygen produced, an amount of carbon dioxide captured, not sunk because we're eating it again and it's just regenerated. So we're not burying carbon dioxide, but we're actually capturing it directly. Amount of nitrogen captured, because there's basically called chemical stoichiometry. If you go back to your chemical lessons, it's like for every gram of seaweed grown or protein made, it required this much nitrogen or this much carbon, and it would produce this much oxygen through the process of photosynthesis. So it's through this just school bench stoichiometry that we can say, here, we've done a kilo of seaweed that contains 30 to 40% protein. So within that kilo of seaweed, we have captured a kilo of seaweed's 5%. So, 50 grams of nitrogen So 50 grams of pure elemental nitrogen was caught to grow this 1 kilo of seaweed. 1.5 kilograms of carbon dioxide was caught to grow this 1 kilo of seaweed, because some of that carbon dioxide is actually then converted to oxygen. So we're also releasing about 1.5 kilos of oxygen in the process as well. So we are reoxygenating the seawater in the coastal zone at the same time. So these sorts of basic principles of stoichiometry can be calculated directly from the amount of seaweed that we produce. And it's just through our science that we can show these things. But it's a little bit tricky because the modern world and their simplicity of trying to account for climate change and carbon capture, it's such a sort of skewed and minor part of the whole process of food, energy, nutrient flows. And so we have to actually work hard at revising and communicating what we do in a little bit of a different way, because people say, oh, can't you get carbon credits for doing this? Well, in theory, we can. But again, that's a complex stoichiometry about how much carbon emissions we avoided in the food production system through growing seaweed and eating it in this way instead of, say, that amount of alternative land-based food. And so it isn't a straight line. And that's what's challenging in this world today, is that if people are looking for a simple answer, and that today the simple answer is carbon credits will solve everything, it's not actually correct. And so we have to work with the customers that understand what we do in a little bit more detail. And that's a bit of a challenge. So we tend to, on the bigger picture, market the seaweed for its health and nutritional credentials, because people understand that better. But slowly in the background, while we're educating them about health and personal benefits from eating seaweed, we start to trickle in the information about, why is this seaweed protein good and complete? Well, because it came from this regenerative source. Or why does seaweed have iron or other trace elements in it that are good for you? Well, because we're recycling clean coastal seawater, not in polluted coastal zones. And we sort of have to slowly combine this messaging, but it's actually a real challenge, because going out there and preaching the science really isn't delivering a viable solution, and we need these solutions to be viable. We need the community, we need business, we need industry, we need everyone involved in environmental solutions, not just regulators. And that's what we're trying to do here, is change the paradigm of how we can fix environmental problems without just relying on regulation or green ticking, carbon credit boxes, because it ain't that simple.
So, Pia, I'm hearing that it's really hard to communicate what you're doing. So you can communicate the health benefits, etc. But why is it so challenging to communicate the environmental benefits as well? Are people just not interested, or is it too complicated? What do you think?
I think especially in this world today, it's too complicated, and people don't have a span of attention to listen to it unless it's their personal interest at school or universities and things like that. It's pretty hard to communicate. And so the world's interested in simple grab lines. And then we actually have to compete. You get companies that come along and jump on these simple grab lines and start greenwashing large existing industries. They're greenwashing business as usual. And we have to then compete with the large business as usual. And that's really hard to do because we're not large and we don't have the economies of scale. And so we have to start educating our customer base, because it's together with our customer base that we create momentum and a movement that starts to appreciate that there is complex science behind what we do, but really it's just about simple regeneration of nutrients, putting it in seaweed, eating it, and starting the cycle again. So it isn't different to a permaculture system. It isn't different to your composts, growing your vegetables in your garden and you eating it again. It's just a different process and players in that cycle, but it's exactly the same concept. And so we have to communicate to people that, this is the ocean-based concept, and it's a really important one because, as I mentioned at the beginning of the interview, one of the biggest waste streams from food is the silent, invisible one of nutrients hitting the coastal system, because everything we do in the food chain ends up in the coastal zone. And that is poorly appreciated. And we're there about putting that story back onto our plates, and eating the solution. And it's a nice story because it's positive. It's like we don't have to bash people on the head and say, you should do this. It's like, here, eat your pasta. and then you'll say, you'll solve the problem.
So, I've done quite a bit of work around, the latest buzz phrase, this circular economy, the principles of circular economy. This is very much about circular economy, what you're doing.
It is. And then that's where it's exactly circular economy. It's exactly regenerative. It's exactly sustainability. It's all of those words. And those words tend to create, a buzz or a theme or debate. So it's not regenerative. This means regenerative. There's lots of, it's not that complex. Regenerative, circular, it just means be efficient with it and reuse it again.
Yep.
And that's how systems on Earth work. And that goes back to the whole foundations of where I started in understanding planetary systems and the flows of nitrogen around the Earth, the flows of oxygen, the flows, because it is all connected. You just have to look at the global weather maps at night and see how the winds and the waters are circling our planet. And we are part of those flows. And if what we did is pull ourselves out of those flows and disrupt them and unbalance them, and really that's all we have to do is start rebalancing them. But we have to start rebalancing them at scale. And it is amazing to be able to produce your own food in the garden and use your compost. And that is one of the things that we all can do. But the biggest part of our food system is industrial. And so we have to make this regeneration industrial, or as big as the industrial scale. And the power of seaweeds to do that is actually phenomenal. People don't appreciate either the power of the coastal ecosystems in regenerating nutrients and the service they provide to us. But take a look at the White Cliffs of Dover. Every single particle in a White Cliff of Dover is an algal cell shell. The whole cliff was built of just algae over thousands and millions of years. And so that is the power of seaweed to regenerate, bury, and nurture the ecosystem around us. And it includes ourselves as well as, the fish or the oysters we're eating from the oceans. And it also includes putting the nutrients from sea, back into the land system, because even plants that we grow on land need the nutrition and the trace elements from the oceans. And so that's where agriculture also has a role in bringing seaweed back into the food production system as part of that large-scale regeneration of nutrients.
I understand you're working with the wheat industry at the moment. What other industries, could really, really make a difference at this regenerate at scale level?
Every single food industry, because we've actually regenerated waste streams from dairy processing and cheese manufacturing, from mushroom waste streams. Mushroom waste actually has a lot of ammonium waste that runs off into the coastal zone. People aren't aware of that. Mushrooms eat, they don't photosynthesize, so they create waste streams as well. And every organism on Earth is comprised of carbon, hydrogen, oxygen, nitrogen, phosphorus, and potassium plus trace elements. And all we're doing is breaking them back to their basics and regenerating them back into the food system. So we can do this with any organic source, which is all food. We just have to trim and tailor the balance of things. For example, if you've got, say, sugarcane waste and there's a whole lot of chaff, it's very carbon rich. So we would need to, say, blend some chicken manure into that to get some of the nitrogen waste, for example. But all of that can be turned back into nutrients. And the one industry that hasn't been embraced in Australia for regenerative energy is biogas plants. And it's the composting of this organic agricultural waste into biogas that can create energy a clean CO2 source and dissolve nutrients. And those biogas plants, after generating the energy, are actually then the feed source for seaweeds. And that's how we operate it at the wheat refinery plant. The wheat waste is digested, broken down to its elemental parts, basically. And while it does that, it creates biogas that is energy for the wheat processing plant. It also regenerates clean water. Potable water can be recovered from the system. And then we get concentrated nutrients that then go into the seaweed. And we could do that biogas regeneration with any organic matter.
So, Pia, looking ahead, what are your goals for expanding the impact of Venus shell systems?
My personal driver is that seaweed could be as big as 10% of the food production industry in its entirety. And why shouldn't it be? Because if we did that in Australia alone, and we replace 10% of the wheat in pasta, we still have our beautiful durum semolina wheat industry pasta there. But if 10% of that was seaweed, which is what we do today in our pasta, we would reduce the need for 1 million hectares of food producing land just by putting 10% of seaweed into our pasta. We would also reduce all of the fresh water that's required to grow that 10 million hectares of wheat. Because we grow in salt water, not fresh water. And we would be able to recover biodiversity systems because we've got land available to do that. And we also protect the coastal zone ecosystems. For example, the barrier reef is overloaded with nutrients, so is the bays around Tasmania, as we all know. And we would protect those coastal zones from these impacts and put oxygen and reduce the acidification of these coastal zones at the same time. So sometimes it's overwhelming how many systems seaweeds help to fix by being at the coastal zone as part of our food system. But that's indeed the role they play in the coastal zone in nature anyway. And because it's under the waves, people don't see it. We're just bringing that service into full view on the coastal land and accelerating it because the load that we're pushing out there requires that we accelerate it.
Well, Pia, that's fantastic what you're doing. The work that you and your team is doing is amazing. It sounds like a real game changer to me. And we really need to get good stories. So it's not just a good story. It's actually a game changer and it's working. So, this is all about regenerating at scale. So thank you so much for joining us today. I look forward to continually hearing how you're going and all the best going forward.
Thanks so much for spreading the word of the many ways we can regenerate food waste.
And that wraps up our conversation with Pia Winberg from Venus Shell Systems. And if you'd like to learn more about what Pia is doing, head over to their website, and I've included the link in the show notes. And as always, if you have questions, feedback, or your own food waste to value story, drop us a line at foodwastematters@honeyandfox.com.au. And don't forget, you can catch up on all our past episodes on YouTube or wherever you get your podcasts. So thanks for tuning into Food Waste Matters. Until next time, keep finding ways to make waste matter. Bye for now.